Hi guys and welcome you all for today's video, and today's video is about the machine learning. So I am Lakshmi Raibabai and we currently pursuing the CSC AI at the College of Engineering. So before getting into the machine learning topics, let's take a few moments for introduction to the machine learning. What is this machine learning? Machine learning is a field of AI that enables the computer to learn from the data without explicit programming, because we are not going to do any external program, so that the machine learns from the feedback, or the what you call it as a grades, nothing but it learns from the situation or the environment, then it adjusts its output according to it. ML algorithms can identify the patterns, make predictions, and perform complex tasks, and empowering the business and the researchers alike. So, we have the concept of supervised learning algorithms. Supervised, nothing but in general terms, supervised means you got a student and a teacher. Here, the students will be having a teacher. Students gonna trained by the teacher. Nothing but in machine in a technical way. Here the data sets are trained and labeled, trained in a labeled way. Nothing but like you know, see here. Because machine learning is a branch of AI that focuses on training models to make predictions or decisions based on a labeled training data. So supervised learning will be having regression, declassification, then decision tree, then SVM. What is this regression? Regression algorithm predicts the continuous values, like predicting the house prices based on the features such as size and allocations. Classification means you're going to get a distinct classes between the classes. So means you're going to there are distinctions, or sorry, the difference between the two classes. Like as I said, I have given examples of the meals. So it gives the two things binary classification. One is whether it is yes or no, true or false. Means one, or a binary way we can say whether it is one or zero. Decision tree. Decision tree uses a tree-like structure to make a decision based on the series of the rules, where you got a root as your condition. Upon that condition, I'm going to generate a tree. The lower, the last node, the last nodes of the trees are called leaf nodes. It gives the output, nothing but whether it is you can do it or not, whether it's true or false. Next is SVM. SVM finds the optimal hyperplane to separate the data points into different classes. Next we have unsupervised. Here, as I said, in supervised we got teacher and student, but here only the students, no labeled data. Here we got two things. One is clustering. Clustering algorithms group the similar data together, like grouping the customers based on their purchase history. Means clustering is nothing but you're going to make a group. Like you got a set of customers. Uh, the one set of customers buys traditional clothes, the other one is Western. The third type is both mixed, Western and tradition. So traditional. So this clustering is the categorizing the specific group of customers into one group. Next is dimensionality reduction. Dimensionality reduction techniques reduce the number of variables in the data sets for simplification of analysis, then improving its performance. Next is association rule learning. Association rule learning identifies the relationships between items in our data sets, like finding which products are often purchased together. Next is end-to-end machine learning projects. End-to-end, nothing but we got a set of stages to be developed. One is data collection. We're going to collect the data from the various sources. Second thing is data pre-processing. Nothing but we're going to clean the data and transform for the data into a format such that it is helpful for your analysis. In data pre-processing, we got first thing is resizing your data. Then we'll go for the normalization. Then third thing, we'll go for the data augmentation. So in end-to-end, uh, as I said, pre-processing consists of a resizing a data. Nothing but you got a variable sizes of the data. You're going to transform the data into a standard size, nothing but into a uniform dimension. Once the data has been resized, you will go for the data normalization. Data normalization is nothing but you're going to convert these uniform data dimensions into a smaller range of the data size. Uh, Let me take an example. See, you got a data, you got image got a pixels. These pixels will be given a number based on its color intensities. So this number will be ranging from 0 to 255. This 255 is not a small range, right? So now you're going to decrease that size into a lower format, like lower value or smaller range of value. But that can be ranging from either 0 to 1, or it can be ranging from -1 to 1. Once the data normalization has been done, why we are going to do this data normalization? So data normalization, if it isn't done, how the ML thinks means it gets confused if it is not in a standard format, because it doesn't it couldn't like it cannot identify the patterns or the important features in that image. But once when it is being resized or once it is being normalized, it helps in for the better understanding and comparing the images. Third thing, we'll go for the data augmentation. Data augmentation is nothing but you're going to add varieties to your data, or you're going to add more characteristics of your data. Like if you take examples of a dog, in the dog, what we do in data augmentation is simply viewing the data in a one view. We're going to data, rotate the dog images in a different angles, or we're going to rotate the data, sorry, the dog image, or we're going to flip the dog image so that you can, like you'll get a idea how dog looks when it's viewed from all the varieties of the angles. Why? Because it helps in the robustness of your computer or your data or your ML model. Then it also helps, like nothing but you're training your ML model such that not only the trained image, such that it can get not only get trained from learn from your trained images, but it also get a learning for the unseen images or the new images. So this is the importance of data pre-processing. Then we'll go for the model selection and the training, then model evaluation. Then nothing but you're going to test your data, or test your model, or you're going to validate your model. So this validation or the testing your data can be done by the back propagation, then error loss testing, then by gradient descent method. So these are the the things comes under the data. Model evaluation. Next is deployment and monitoring. Make the model available for use and monitor its performance over the time. So this is the end-to-end machine learning project. Components of the end-to-end machine learning project. Next, we have SVM. In SVM, we have three types. One is linear SVM, polynomial SVM kernel, then radial basis, and we got many more. So here, linear SVM finds the best hyperplane to separate the data points in a linearly separable data set. Next is polynomial kernel. Polynomial kernel maps the data into a higher dimensional space, allowing for non-linear separations. Next is RBF, radial basis function. RBF kernels creates a boundary around each data point, allowing for the complex non-linear separations. Next is what is the importance of ML in a real world application. First thing is healthcare. It helps in diagnosis of your, the X-rays, or it helps in drug discovery. Then customize your medicine or personalize your medicine. Next, finance, like it helps in uh, business analysis, the stock market price predictions. So next, fraud detection, e-commerce, like it provides the recommendation according to your history of the shopping, then the advertisement based on which you have to create, then customer to customer segmentation. So these are the benefits of the machine learning in the real world applications. Uh, yeah, guys, that's all. Thank you.